Today we are going to learn about preparation methods and properties of glucose. So first of all, glucose, it is one of the monosaccharide molecule. This molecule belongs to carbohydrates, but these carbohydrates are divided into different categories on the basis of hydrolysis. First one monosaccharides, second one oligosaccharides, third one polysaccharides. Glucose is monosaccharides. Chemical formula of glucose is C6H12O6. This is a chemical formula for glucose. This is a chemical formula for glucose. This molecule react with water, do not decompose to other units. Okay. So why? Because this is a monosaccharide unit, and this monosaccharide is reducing sugar. So the glucose is one of the reducing sugar. So this molecule exhibits Mota rotation. This molecule exhibits Mota rotation. Okay, students, next the glucose is one of the carbohydrates. This glucose molecules is used to increase a lot of energy for human being's body, and this is one of the energy store particle for different living organisms. This is the importance of glucose. Okay, this glucose is reducing sugar, and this is one type of sugar category, means this molecule react with water, some sweet character is exhibited. That point is based on these molecules are known as sugars, and this is monosaccharide, and this is reducing sugar, and this molecule is exhibits Mota rotation, and this molecule is exhibits dextrorotatory. This molecule is exhibits dextrorotation. Plus D configuration is exhibited. So generally this molecule react with water, or this molecule is observed in the presence of water. The molecule rotates clockwise direction. This molecule rotates clockwise direction. So this type of particles are known as dextrorotated particles. These are known as D plus rotated particles. Okay. So this is the introduction for glucose. And next I am going to discuss preparation methods of glucose. Preparation methods of glucose. Students, glucose is prepared from sucrose. Sucrose is one of the carbohydrate molecule, but this is a disaccharide. Disaccharide means this molecule react with water. It's dissociated into two units. The type of molecules are known as disaccharide molecules. Such type of molecules are known as disaccharide molecules. For example, C12, H22 O11. This is a chemical formula for sucrose. Sucrose react with water in the presence of acidic medium. Sucrose is one of the disaccharide molecule. This molecule react with water in the presence of acidic medium. It's dissociated into two units. That units are C6H12O6 plus C6H12O6. So this is a chemical formula for glucose, and this is a chemical formula for fructose. Sucrose react with water in the presence of acidic medium. It is dissociated into two units. One of the unit is glucose and another unit is fructose. Okay. And next one, starch react with water to produce different types of glucose molecule. For example, n moles of C6H5 O10 molecules react with water to produce NC6H12O6, C6H10O5. C6H10O5 molecules react with the waters to produce n moles of C6H12O6. Means in H2O molecules, two hydrogens are ejected in this way and another oxygen atom is ejected in this way. Totally these molecules are converted to glucose. Okay, so these two methods are best preparation methods for glucose. First one, sucrose C12H22O11. This is a chemical formula for sucrose. Sucrose react with water in the presence of acidic medium. It is converted to glucose and fructose. And next one, starch react with water. It is converted to glucose. Means, so the large amount of glucose is prepared by using this method. So the limited quantity of glucose means it is used in laboratory purpose. The type of glucose is prepared by using this method. So these two methods are best preparation methods of glucose. Okay, this is an explanation of preparation methods for glucose. And next one, properties of glucose. Properties of glucose. Properties of glucose. Students, generally glucose is one of the reducing sugar. It's react with Tollens reagent. It is converted to, it is produces silver mirror. It's react with failing reagent to produce red color precipitate. And so many chemical reactions are involved in this molecule. So few examples. First one, few examples. Glucose react with concentrated HI. Glucose react with concentrated HI. Students, glucose, like chemical formula is C6H12O6. This is a chemical formula for glucose. This is a chemical formula for glucose. Glucose react with concentrated hydrogen iodide. Glucose react with the concentrated hydride. It is converted to hexane, N-hexane. It is converted to N-hexane. N-hexane, or the chemical formula of N-hexane is, so this one, CH3, CH2, 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 CH3. Means 6 number of carbon atoms are there in the chain. This is a straight chain. Totally 6 number of carbon atoms are there. That point is based on, this is known as N-hexane. Okay, simply this reaction is clearly observed. The glucose react with the concentrated HI. It is converted to N-hexane. Okay, this point is based on glucose contains 6 carbon atoms. Glucose contains 6 carbon atoms. This point is based on glucose containing 6 carbon atoms. And the second one is observed. Glucose react with hydroxylamine. Glucose react with hydroxylamine. Means NH2OH. Glucose react with hydroxylamine. Okay, the glucose react with hydroxylamine means C6H12O6. Glucose react with hydroxylamine NH2OH to produce C double bond N OH. Means some oximes are formed. So, and remaining atoms are OH, H, CHOH, CHOH. So next one 4, 5C, H, OH, CH2OH. Anyhow, this part is out of matter. Only first one. So it is formed oxime. Okay. So this part is out of matter only. Glucose react with hydroxylamine. Only it produces oxime. That point is based on glucose contains one aldehyde group. That point is based on glucose contains one aldehyde group. That point is identified by using this reaction. Glucose react with hydroxylamine, so it produces oxime. That point is based on glucose contains one free aldehyde group. And next one, third property is glucose react with cyanohydrine. Glucose react with cyanohydrine, HCN. Glucose react with cyanohydrine means, so the glucose chemical formula is C6H12O6. Glucose react with cyanohydrine like HCN. So means hydrogen cyanide. Glucose react with hydrogen cyanide, not cyanohydrin. Glucose react with hydrogen cyanide. Hydrogen cyanide. Glucose react with hydrogen cyanide to produce this is another part of glucose, to produce cyanohydrin, to produce cyanohydrin. Okay, glucose react with hydrogen cyanide to produce cyanohydrin. This point is based on, this reaction is based on glucose contains free aldehyde group, Glucose contains one free aldehyde group. Okay, so first one, glucose react with the concentration hydrogen iodide, it is converted to N-hexane. This point is based on glucose contains 6 carbon atoms. And second one, glucose react with hydroxylamine, so it is produces oxime. This point is based on glucose contains one aldehyde group. And third one is glucose react with hydrogen cyanide, so it is converted to cyanohydrin. This point is based on glucose containing one free aldehyde group. And fourth one, glucose react with bromine water. Glucose react with bromine water. Glucose react with bromine water. So this is a chemical formula of glucose, C6H12O6. Glucose react with bromine water. It is converted to gluconic acid. Gluconic acid means COOH, CH, OH4, CH2OH. This molecule name is gluconic acid. Gluconic acid. Okay, the glucose react with bromine water, it is converted to gluconic acid. This reaction is based on glucose structure is observed, it is confirmed one aldehyde group. Okay, glucose structure contains one aldehyde group. This is confirmed. Means this is a confirmation test. Okay, once again recall in these methods. First one, I am going to discuss glucose. So this is one of the carbohydrate molecule. This is a monosaccharide. This is a reducing sugar. It is exhibits mutarotation, and it is also exhibits dextrorotated molecules. Means it is exhibits dextrorotation. So now preparation methods of glucose. So the glucose react with water in the presence of acidic medium. It is dissociated into glucose and fructose. Now another preparation method is the starch react with water. It is converted to glucose. Now properties of glucose. Glucose react with concentrated HI. So the glucose molecule is converted to N-hexane. So this reaction is based on the glucose contains 6 carbon atoms, and the glucose react with hydroxylamine to produce oxime. This point is based on So the glucose contains one aldehyde group. Now another reaction is glucose react with hydrogen cyanide. So it is produces to cyanohydrin. This point is based on glucose contains one free aldehyde group, and the next one is glucose react with bromine water. So it's react with bromine water, it produces gluconic acid. This point is based on one CHO group is must and should. It contains one CHO group. So this is the confirmation test for presence of aldehyde. Glucose react with concentrated nitric acid. Glucose react with concentrated nitric acid. So students, the glucose is general, the structure of glucose is this is a glucose structure or the similar structure of glucose. This is the glucose. Glucose react with bromine water. Bromine water is act as a mild oxidizing agent. Glucose react with bromine water. It is converted to gluconic acid. And another one, the glucose react with concentrated nitric acid. Glucose react with concentrated nitric acid. It is converted to succinic acid or saccharic acid. So this is the glucose, the formula is C6H12O6. So this is a similar structure of glucose. Glucose react with a mild oxidizing agent like bromine water. It is converted to gluconic acid. That is one way. And another way is the same molecule glucose react with strong oxidizing agent. Strong oxidizing agent like concentrated nitric acid. It is converted to succinic acid or saccharic acid. The formula of the structure of saccharic acid is this one. Okay. In this reaction is observed, the first carbon, it involves aldehyde group. The aldehyde group react with a strong oxidizing agent. It is completely converted to carboxylic acid. So the aldehyde react with a mild oxidizing agent. This is also converted to carboxylic acid. So both are same. So the aldehyde group react with a mild oxidizing agent or strong oxidizing agent. So this is converted to carboxylic acid. So means one aldehyde group is present in it. This is a real fact by the announcing of previous chemical reaction on the basis of previous chemical reactions. And next one, in this reaction is used to identify one primary alcohol group is present in it. This reaction is observed. It's react with strong oxidizing agent like glucose react with strong oxidizing agent. It is converted to saccharic acid. Saccharic acid. This reaction is used to identify glucose contains one primary alcoholic functional group. Glucose contains one primary alcoholic functional group. Why? In generally, the primary alcoholic functional groups react with the strong oxidizing agents. These are completely converted to carboxylic acids. Okay, so this is a primary alcoholic group. These primary alcoholic groups react with a strong oxidizing agent. So the primary alcoholic group completely converted to carboxylic acids. Okay, this is a glucose react with a strong oxidizing agent. So finally this reaction is used to identify so glucose containing one primary alcoholic functional group. One primary alcoholic functional group. Okay, this is the importance of this reaction. And next one, another property is glucose react with acetic anhydride. Glucose react with acidic anhydrides. Generally, glucose, the structure of glucose is CHO, CHOH4, CH2OH. This glucose react with excess acetic anhydride. Glucose react with excess amount of acetic anhydride. It is converted to pentaacetate. That is CHO, CH3, 4, CH2O, CH3. This is glucose pentaacetate. Okay, students, this reaction is clearly observed. This is the glucose. Glucose molecule react with excess amount of acetic anhydride. It is converted to glucose pentaacetate. This reaction is based on the glucose containing 5 hydroxyl groups. 5 hydroxyl groups are present in it. Okay. So this glucose react with acetic anhydride, means glucose react with excess amount of acetic anhydride. It produces glucose pentaacetate, means the 5 hydroxyl groups are connected with acetyl groups. So these are formed such type of adduct products like 5 acetyl groups are connected in this molecule. This point is based on glucose containing, this reaction is based on glucose containing 5 hydroxyl groups. Glucose containing 5 hydroxyl groups. Okay, so this reaction is based on to identify glucose containing 5 hydroxyl groups. Okay, previous properties are based on first one, glucose react with concentrated HA. It is converted to N-hexane. That point is based on glucose containing 6 carbon atoms. Glucose containing 6 carbon atoms. These properties are based on to identify the structure of glucose. To identify the structure of glucose. The first property, glucose react with concentrated HA. The glucose is converted to N-hexane. That point is based on glucose containing 6 carbon atoms. First one, glucose containing 6 carbon atoms. Okay, 1, 2, 3, 4, 5, 6. Glucose containing 6 carbon atoms. And the second one, this is the basic skeleton of glucose. And the second one, the glucose react with hydroxylamine. It is converted to oxime. This reaction is based on glucose containing one aldehyde group, means the first carbon involves aldehyde group. The first carbon involves aldehyde group. And it is also react with hydrogen cyanide. It is converted to cyanohydrine. That reaction is also used to identify the given glucose structure containing free aldehyde group. So that is the first carbon. First carbon involves aldehyde. Means these two reactions are based on the first carbon in glucose it contains one aldehyde group. And next one, glucose react with mild oxidizing agent like bromine. Mild oxidizing agent like bromine. It is converted to gluconic acid. Gluconic acid structure is observed. The first carbon involves carboxylic acid and remaining structure is same. So means that point is based on the mild oxidizing agent react with aldehydes. It is converted to carboxylic acid. So that is enough. That is the first point. And second one is, and next one is, glucose react with strong oxidizing agent. Glucose react with powerful oxidizing agent or a strong acid like HNO3, concentrated nitric acid, react with glucose. It is converted to saccharic acid or succinic acid. It is converted to saccharic acid. In this structure, the first carbon and last carbon, both carbons are involved for the formation of carboxylic acid. Means, so this is a reaction. This reaction, the last carbon involves formation of carboxylic acid. This reaction is based on, so the primary alcohols react with strong oxidizing agent. These are converted to carboxylic acid. That reaction is based on the last carbon is involves primary alcoholic group. The last carbon is involves the formation of primary alcoholic group. Okay. And next one, glucose react with excess amount of acetic anhydride. Glucose react with excess amount of acetic anhydride. it is converted to pentaacetate of glucose or glucose pentacetate. Means 5 hydroxyl groups are there. Especially the last carbon is the primary alcoholic group and the middle part of 4 carbons are also connecting hydroxyl groups. Okay. So carbon valence is 4. All carbons are satisfied by valency. Okay. So totally 5 hydroxyl groups are there. The first carbon involves aldehyde group for the formation of aldehyde group, and 4 carbons are connected secondary alcoholic groups, and the last carbon is a primary alcoholic group. Okay. Finally, this is the structure of glucose. On the basis of chemical properties, this is the structure of glucose. Now, I am going to discuss some of the special points of glucose. So now glucose is monosaccharide. Monosaccharide. It is exhibits mutarotation. What is the meaning of mutarotation? What is the meaning of mutarotation? Okay, first one, glucose. First, dextroglucose, D-mannose, and D-fructose. Okay, students, these are similar to glucose structures, but a slight variation is there. But a small variation is there. Both the these molecules all are monosaccharides. Structures are similar, but a slight variation is there. Okay. These are isomers. These 3 units are isomers. Why? What is the reason? For example, glucose react with Tollens reagent. Tollens reagent. It is produces to silver mirror. And also glucose react with failing reagent. It is produces to red color precipitate. Red color precipitate. Okay. But fructose structure is observed. Fructose structure containing one keto functional group. But this molecule is also react with the Tollens reagent. Why? What is the reason? Fructose containing the fructose structure is observed. Fructose is one of the monosaccharides, but the glucose structure and the fructose structure both are observed. Glucose containing one free aldehyde group. So that's why it's react with the Tollens reagent to produce silver mirror. That is a real fact. Why? Only the property of Tollens reagent is to identify the given carbonyl compound containing aldehyde or not. So that is a duty of Tollens reagent. And also similar failing reagent duty is same. Failing Tollens reagent and a failing reagent. So what are the main duty of these two reagents? So many carbonyl compounds are there that the given these two reagents are identified. The given carbonyl compound containing aldehyde group present or not. So the given compound containing aldehyde group or not. That is the main duty of these two reagents. For example, the given compound containing aldehyde functional group, it produces silver mirror. So the given compound containing aldehyde group, it's react with failing reagent, it produces red color precipitate. That is the identification of aldehyde functional groups. But the fructose structure is observed. Fructose structure containing one keto functional group. One keto functional group. But this molecule is also react with Tollens reagent. It produces silver mirror. Why? So the fructose containing keto functional group, but this molecule react with failing reagent to produce red color precipitate. Why? What is the reason? So only one reason is there. These are isomer units. These are isomer units. That is the only one reason. These are the isomer units. That is only one reason. And next one, all monosaccharides and disaccharides except sucrose, these are the reducing sugars, and also these are exhibits mutarotation. These are exhibits mutarotation. So D-glucose and equilibrium mixture and glucose. Okay, so the D-glucose observed in the presence of water, it is rotated with 111.2 degrees, and so after some time, so it's dissolves in water 50%. So it is converted to 52.2 degrees, and so the total rotation it changes, it is converted to 19.2 degrees. Why? What is the reason? Means these are the optical active compounds. So the rotation it changes in the presence of water. So the specific rotation it changes in these optical active compounds. That changing the rotation, that changing the process of change the specific rotation, that is known as mutarotation. That is known as mutarotation. Okay, generally monosaccharides and disaccharides except sucrose, these are exhibits mutarotation. Okay, so this the change the specific rotation in the presence of aqueous medium, that changing rotation is known as